All right, stat students, we are in practice mode at this point. There's nothing new being presented, but we definitely need to take this this week and practice skills. Let's see, last week I sent out a quizzes to you guys, and I'd highly recommend you practice with that because part of your test, which is going to be on the, let's see the date there. The test will be on the 17th for you all. That's the game plan, at least. On the 17th, you guys will be taking your test. So I want to make sure that you practice enough with the symbols. Anywho, we're going to go ahead and practice a little bit today. So this video is all focused on making you guys better at answering the questions that are asking you to solve for probability. So let's get started. Okay, so we are going to start with this slide here, okay? So what you see on this slide, and I'm even gonna make this large. I think this will work. I'm not so sure that that's working. I need to just move my camera out of the way. Oops. Can I grab my camera? Come on. All right, so you are going to match each symbol that you see here. So we have S of X, sigma of X bar, sigma of P hat, and sigma just by itself. So we have all four of these, and all but one of these is going to match to one of these standard deviations. So right now, this is what can be so confusing about this class, is that we have four symbols that represent standard deviation, okay? So right now we want to sort these out. Here are the distributions. We looked at these from the Gettysburg Address situation. Here's the population data. This is all the Gettysburg Address population data, and we get its standard deviation. Here is a single sample. I took samples of size 30. So this is the distribution for one sample. Okay, and here's their standard deviation. And then the last one here, this is the sampling distribution of the means of, we have 20,000 samples that I took here, 20,000 samples. Here's the standard deviation of that. So we need to match up the symbols that go with this, okay? So I'm going to give you a moment. I want you to think about this. And I don't really have a way to make, I guess I could do this. We could label this is A, B, C, and this is 1. Actually, let's do it the other way. We're going to do this. So this is A, B, C, D, and you're going to match them up to 1, 2, 3. All right, so I'm going to do a multiple choice. That's what I'm going to do. So you have a multiple choice. I'm going to say, okay, number 1, is it A, B, C, or D? 2, is it A, B, C, or D? 3, is it A, B, C, or D? One of them is not going to work. So you'll, through process of elimination, we'll find that out. Okay. But I'm going to go ahead and pause and let you try to figure out which one goes with which. Okay. All right. So you had time. Also, this D is bothering me. So you had time to work through that. It's not much better. It looks like a P now. You had time to work this out, and I think that it scores you automatically. I can't remember, but let's go ahead and talk about this. First off, we have the standard deviation this is the population data. This is everything. So our symbol for that is sigma. Okay, that's what that standard deviation represents. Your population standard deviation. On your, we have a practice worksheet that I just put up on Kidem yesterday. You have all of these symbols here. On number 3, 2, it sort of looks like it's part of 2, but it's not. Might even drag that down. I can't really. So, but this is number 3. You have to define each symbol. So here is this second symbol. You would write population standard deviation next to that one, because that one is representing the entire population. This is all the words of the Gettysburg Address. Okay, so number 1 should have been D. Let's look at the middle one here. This is a sample distribution, and the symbol for sample standard deviation is the first one we ever learned. This is what you get when you do the 411 in your calculator. The sample standard deviation, that's what this is. This is a single sample, and there's its standard deviation. It's how spread, it's the average distance to its mean of all these points. Okay? Now, lastly, we have these two symbols here. These both represent sampling distributions of sample. Well, it's just the standard deviation of sampling distribution. So here we have our sampling distribution of, this is sample means at the bottom. You can see that here. So which symbol represents means? Is that X bar or P hat? Well, it's X bar. So this one goes here. So that means that sigma of P hat is actually not being used here at all. Well, why is that? Well, P hat represents proportions. I don't even feel like writing. I've been writing a lot by hand here, so I'm going to put in a text box. So proportions is what this one represents, and we never even considered creating a proportion for the Gettysburg Address. We weren't interested in that. We wanted average word length. So when I see the word average, I should think, oh, it's means, it's X bar. That's what we're talking about here. Okay, so that's really the point of this exercise, is to get us a little more experience with the symbols. Okay, again, you have to be able to name all the symbols. So what we have here, S of X is sample standard deviation. Here's population standard deviation, sample standard deviation. Okay, how would we write these other symbols? This is I think we've already written it out at least once. This is the standard deviation of the sampling distribution. My screen, this is in the way. This is a very long descriptor here. Distribution. Can I not edit this? What is going on? Of sample means. This is the descriptor for this one here. Okay, now for this one, you just replace the word proportions. So you do the same thing, except you use the word proportions instead. Okay, sample proportions, that's what that is. So we don't actually have this one in this case. Okay, it does not belong here. All right, so that's how we're getting things started today. We're talking about these symbols. So the next thing we want to do, which we only have, we're going to look at some examples here. Okay, we're going to talk about how you want to answer questions. So on this practice worksheet and a lot of the problem sets, starting at number 10 here, we want to talk about how to interpret questions like 10 through 13. Okay, how do you approach those questions? Okay, well, I've got two example problems that we're going to look at to start with. All right, I'm going to move my camera again. I'm having to like put myself in a corner over here. That's fine. Okay, right there. All right, so we have two situations here. We have who owns a Harley and bottling cola. All right, one of them is a situation of X bar. One of them is a situation of X bar, and one of them is a situation of P hat. So I'll put A and B again. This is going to be 1 and 2. Okay. So I want you to read each situation. I want you to determine, is this a scenario that involves X bars or a situation that involves P hat? Okay, so we know X bars is means, P hat is proportions. All right, so I'm going to pause and let you try to decide that. All right, so for these, you should have put, for the one with the Harley, you should have put B. This is proportions. And that means that this one is A. So let's talk about how we determine that. So when you're talking about proportions, proportions is part to whole relationship. And when you deal with proportions, a lot of times you'll see the word proportion in the statement, or you'll see percents. And whenever I see percents, that always tells me that I'm dealing with proportions. Okay, so we'll write that up officially in a second. Next, the means. There's a couple things that I'm looking for. Well, first off, I see the word mean right here, and as soon as I see that word mean, that means that it's X bar, okay? Also, if I see the symbol mu, or if I see the symbol sigma, that's also another sign that I'm dealing with X bars, okay? And interpreting the scenario is the first step for success when you're working these questions, okay? Because we have our list of rules that we use to answer them, okay? So I've got this slide here, and I hand wrote it all, so it looks pretty bad. So I apologize about that. I might get a better handout for you. But AP students, you already have a lot of these rules. I think you have almost all of these rules in your formula sheet. However, dual credit students, this is not in your formula sheet at all. Okay, so this is something that'll have to be that you can't use on a test. You're not allowed to use these rules on your test. Okay, because you won't have them on the dual credit test. All right, so these are the rules, and we're going to write down. How do we know that it's p hat? Well, you're going to either see the word proportion. My text box there. You'll see the word proportion. That tells you it's p hat. You'll see percentages, fractions. That's really what you're looking for when we say proportions. Now, somebody yesterday had said, well, they thought that that 2 was a p hat because it's supposed to contain 300 milliliters. And it's just a part of that whole bottle, and they thought that was proportion, but that's not really what. Sometimes you can sort of read into these problems, but what you're really looking for is the key terms in there. You're looking for the percents to make it proportion, mean, mu, sigma to make it X bars. Okay, so we'll go ahead and write that over here. We're going to insert another text box. So to identify means, you're looking for the word mean. You're looking for the symbol mu or sigma. You're looking for those symbols to tell you, because here's why, and I'm going to draw. You're only ever going to see mu here, okay? Let me add another part to this as well. Oh, whoops. If you see the letter P, or if you even see p hat in there, that also means that it's proportions. But you'll notice in here, in all of these problems, we have sigma here, mu, and this is the only one that ever is going to have just plain old sigma. So over here we don't have that. Here we have p, right? And so when we see p, that means we're going to use proportions. Okay, so that's where those symbols are coming from. Now, if you want to pause the video and write down these rules again, like on a separate page, feel free to do that, because you are going to want to have these handy to be able to answer questions like question 10, okay? But we're going to take the next few minutes of this video and we're going to be answering these questions right here, okay? So we're going to start by, how do we approach questions and answer them here, okay? Well, every time you work a question in this chapter and you see the word how likely, or what is the probability, okay? All right, how likely, or when you're finding a probability, we're going to be using a normal CDF. That sort of should be the first thought that goes in your head when you see how likely, or what is the probability. So that also means we need to pull up our calculator. Make sure that you have your calculator with. So we pull up our calculator, we have menu, probability, distributions, and we want a normal CDF. And here is all the information that we are going to end up needing to type in here to get our answer, okay? This is what we're going to need to type in to get that, okay? So let's continue with this question, and let's talk about the first thing that has to be checked. We go over here, we know that this is a p hat situation. For us to use a normal or to do a normal calculation, it has to be normal. So I'm going to go ahead and tell you, the first thing you want to check is normality for all of these problems. So we're going to be using this rule right here. n times p greater than or equal to 10 and n minus p greater than or equal to 10. So I'm going to paste that in. Okay, so we're going to do that. And we need to identify these parts. So what is n? N is the sample size. So what is the sample size here? Well, we're taking an SRS, a simple random sample of 500. Okay, so 500 times P. Well, what's P? Well, that's the population proportion, or the probability. So it says Harley-Davidson motorcycles make up 14%, and it's saying how likely is your sample to contain 20%? Well, this is the true population proportion, so we're going to put 0.14. So we need to make sure that that's greater than or equal to 10. So I need to actually hide this for a second. We need to do that calculation. So 70. Is 70 greater than 10? Yes, it is. So that's good. We do it on this side as well. 500 times 1 minus 0.14. Is that greater than or equal to 10? And it actually will be the complement of this one because it's everything else. So this should be 430, which is going to be larger. So you have to confirm that both work before you can say, okay, this is normal. That means it's going to take on a normal shape. Okay, so we've got that. All right, and a 500 sample size is pretty large. All right, so it is in fact normal. So we can do the menu 552. We can do this normal calculation. So what do we need to do that? Well, we need the mean and we need the standard deviation of this sampling distribution. Okay, so how do we calculate the mean? Well, the mean, we have our rule here. The mean is equal to the parameter. I'm actually just going to copy it. Okay, so the mean is equal to the population parameter. That's always going to be true. So we're going to move that in. So there's our rule. Okay, well, what is that population parameter? Well, it's 0.14. So we know that our mean is going to be 0.14. So when I'm on my calculator, there's going to be a 0.14 that goes in there. Okay. Now we need to calculate the standard deviation. We go back to our rule list here. Here's our standard deviation. Let's type this in, or let's move this over. Use this rule. Okay. Now let's do this, let's figure this out. Well, I can't actually calculate the standard deviation if this rule is not met. This is that 10% condition. And so I need to make sure that my sample size of 500 is less than or equal to 1/10 of the population. Well, what is the population here? Well, it's all Harley-Davidson, or excuse me, it's all the registered motorcycles registered in the United States, excuse me. And the population is motorcycle owners, okay? Motorcycle owners is the population. Well, how many people own motorcycles? There's a lot, right? It's not infinite, but this is large enough. It's sufficiently large, okay? To where we're not gonna break any independence issues, okay? So that means once we've confirmed that that works, we can calculate our standard deviation. So it's going to be P, which is 0.14, times 1 minus 0.14 over N, which is 500. All right, so let's get this value. So again, I'm going to have to exit out of that. I'm going to make a radical, so control x squared, and then a fraction within that, and I'm going to do 0.14 times 1 minus 0.14 over N, which is 500. So there's my standard deviation. I'm going to round to 4 places, so 0.0155. Oops. 0.155. All right, and now we pretty much have everything we need to do this normal calculation. We've verified all the rules we needed to. We know that it's normal. We can actually do this calculation. So it said, how likely is your sample to contain 20% or more? Okay, 20% or more that own Harley. So we're going to go in here. Now we can finally do this properly. 552. 20% or more. So that we have our lower boundary. The lower boundary is going to be 0.2. We always put the decimal version of these percents within here. Okay. The upper boundary, you can put 9, you can use this double E99, where basically it's positive infinity. You could get away with putting a 1 in here if you want to, okay? It should work, okay? But I like to always be in the habit of using infinity, so I don't have to even worry about it once I have my boundary. We have our mean of 0.14, and then we just got our standard deviation of 0.0155. So we hit OK. There's our probability. It is a very small probability, as you'll notice, which is still fine, okay? You are going to get questions that have really minuscule probabilities. So I'm just going to round them. I'm just going to put that 4 zeros and a 5. So 0.000 all the way to 5. And we've answered the question, okay? You would want to repeat these steps on all of these questions. Now let me go ahead and tell y'all, if you check these conditions first, right here, if you check normality and it fails, you don't even have to do the question. Don't do the question, because you technically cannot answer the question because it fails that probability. AP students, this is something, if it's a free response question on the AP test, you'll want to check, because they're making sure you understand that these conditions are what allow you to do the problem. And if you somehow get a question where the condition doesn't work, you would say cannot be calculated due to the non-normalcy of the distribution, okay? That's what you would want to put, but in this case, they are normal. All right, let's try this one here. This will be the last example. See, we're 21 minutes in, okay? So let's do this last example here. All right, so bottling cola. So a bottling company uses a filling machine to fill plastic bottles with cola. The bottles are supposed to contain 300 milliliters. In fact, the contents vary according to a normal distribution with a mean mu and a standard deviation of sigma. So the first thing we want to do is we want to know, is it normal? That's the first thing we want to know. Let me change colors here. We'll go green. Is it normal? Well, how do we check normality? Okay. Well, here are the two ways to do it. It's going to be normal, since this is X bar. It's going to be normal if the sample size is greater than or equal to 30, or if the population is stated as approximately normal. Okay. Well, we don't know our sample size yet, but if I read part A, it says, what is the probability that a randomly selected bottle contains less than 259 milliliters? Well, A randomly selected means n equals 1. Right? And then in part B it says 6, so that's n equals 6 for that second part. So that means the sample size isn't large enough to be normal based on this rule, but is the population stated as normal? It says, in fact, the contents vary according to a normal distribution. So it says it right here. So we're going to say it's stated normal. What does that mean? Well, that means we can perform normal calculations on the distribution. So if we're going to do a calculation here, it says what is the probability? So we need a norm CDF for this one, that a randomly selected bottle contains less than 295 milliliters. So we need, we're going to have to go back through here and do mu, what is the mean, and what is the standard deviation? Well, our rule for mean is, and I'm actually going to copy both of these this time. Here's our rules for mean. Okay, make that a little smaller. The mean of the distribution is equal to the population mean. Well, they give us the population mean and they say it is 298. So there's our mean. That's going to go in here. 298. Wrong. That's standard deviation. 298. Okay, that goes in there. Sigma. Well, or the new standard deviation, it's sigma over square root of n. Well, we also need to check this condition. So for this first one, we're taking 1, and they need that to be less than or equal to 1/10 of the population. Do we know the population? Well, it's just of all, you're taking one selected bottle from this company's filling machine, which it probably does a lot of bottles. We don't know the sample size, the population, but we'll say it's sufficiently large. Now let's calculate our standard deviation. It's going to be sigma, which is 3, over square root of n. N in this first problem is 1. Okay? N in the first problem is 1. So we'll have to change that because the next one is going to be 6. So we will change that in a second. But let's go ahead and answer this question. It says less than 295 milliliters. The standard deviation, 3 divided by square root of 1, well, square root of 1 is 1, so it's just 3, so it stays the same. So let's do the standard deviation, stays as 3. It says less than 295. So we already have negative infinity in here. We'll leave it like that. And we want it to be less than 295. And we hit OK. So we get 0.1586. 1586. And that's going to be the answer to this problem. Okay? I'm going to change colors to show the difference in the way that these are worked. So now we're going to change it for part B. We need 6. So what that does is it changes our standard deviation. When we increase standard deviation, it gets smaller, right? So this is going to be our new calculation. So I'm going to write it here. 3 divided by square root 6. And we also have to recheck, is 6 sufficiently large? Well, yeah, it is. 6 is going to be less than or equal to, and I see my camera's in the way again. 6 is going to be less than or equal to 1/10 of the total population. So we need 3 divided by square root of 6. So I'm going to make a fraction, 3 square root of 6. So our standard deviation is 1.22. And now we're just ready to go ahead and calculate what is the probability. So we need a norm CDF. I really wish I had my Mobi pad going. This mouse is, I'm getting a hand cramp from this. So let's do a normal CDF, menu 552, and it wants less than 290. So it's the same exact calculation. The only difference is the standard deviation changes. So this is still 298, still the same mean, so 298. But we change our standard deviation to that 1.22. That's what we got down here for this orange one. We hit OK. Oh, I typed. Hold on. That should work for you. Somehow I had the letter J in here. There we go. So we get a much smaller deviation this time, and it is 0.0069. That round up? It should round up. So we'll just say 0.7. So that would be, this would be 7. We'll round to 3 places. So that's going to be our answer to this one. Okay. So that's how you're going to be working these questions. Again, I need you to start practicing questions 10 through 13. Of course, you can work some of the other ones on here, but that's what I want you guys to be working on to start this week. We can look at some of the other problems on here. You also need to be working on the ones in the problem set, but that's at least a good start for us getting some practice in for these questions. So always check normality and the 10% condition first. If it fails those, then you just move on, okay? If it fails those, you move on. If you need me to check any of your answers, I can definitely do that for you. Just reach out to me. But I'm going to stop the video here.